Welcome to another video of Java Under the Hood, the first one about the keyword static. In this demo I'll focus on static properties. Static methods are dealt with in the next video. So what does static mean? The word static in the context of Java is kind of misleading. Beginning Java programmers often associate static as something that doesn't move or change, like a statute. A variable declared static is sometimes interpreted as a variable of which its initial value can't be changed or is constant. Java, however, already uses a keyword for constant variables, namely final. So what does static mean then, and how is it implemented in memory? This is what you'll discover in this demo. I'll use class bank account, of which the UML class diagram is displayed here. Three properties: the name of the customer of type string, the balance of type float, and the property it is all about in this demo, the interest rate of type float. Now, unlike the name of the customer and balance, interest rate is not a property that is specific for any bank account. It should be the same for all instances. That is a specification. In the first implementation, we declare all three properties as instance variables. And we're also interested in the setter of interest rate. Client code might look like this. Two bank account objects are created, for which the interest rate is set to the same value. It should be, according to the specification. But one might wonder, is this a good implementation? Let's see what happens in memory. The stack frame of the main method is already set up. Then the creation of the first bank account. The structure of the object on the heap is dictated by the declaration of the three data members in the class, so customer, balance, and interest rate. Since all three are declared as instance variables, non-static, space is reserved for each one of them in the object. Have a look at my video about the inner structure of an object for more information. A similar story for the second bank account. The account for Anna is created on the heap and all properties are initialized. Now, how do we change the interest rate for an account? Well, since each account has its own interest rate field, we access it by using the setInterestRate instance method using a specific reference variable. So for changing the rate for Bob's account, we use account1reference. In the next video, I'll jump into an instance method, but for now, enough to say that this method will indeed change the interest rate for Bob. As interest rate should be the same for all instances of bank account, Anna's interest rate is set to the same value as Bob's. And this is what we do. But hey, nothing prevents me from setting it for Anna to another value. For instance, 0.08. Now, have a look at these values. Does that make sense to you? Well, it shouldn't. Because by allowing this, we break the initial specification of interest rates, namely that it should be the same for all bank accounts. The problem is that interest rate is not properly implemented. It will be if we detach this property from any instance of bank accounts. And how do we do that? That's where static comes in. Our new implementation looks like this. The only difference with the previous one is that now the interest rate property and the getters and setters are now declared static. This will influence how we should call the setInterestRate method. But let's focus first on the creation of the bank account objects. What impact does static have in memory? Let's find out. Let's re-examine the creation of bank account for Bob. Now, when our application starts up, every time the Java runtime bumps into the first usage of the bank account class, which we suppose happens here upon creating the bank account for Bob, the JVM class loader loads the class file in the method area, And this time, before creating the actual object on the heap, since the class now has a static interest rate variable, memory for this variable is allocated first in the method area as well and initialized to its default value of 0. And this will happen only once. After that, the object is created on the heap. But note a difference here. Interest rate is not part of the object anymore. And similar for the second object. How can we change the interest rate afterwards? By invoking the static setter interest rate. Static methods will be explained in the next demo, but for now we change the value to 0.05. To resume, static properties are stored only once in the method area and are not part of any object on the heap. Voila, that's it for this demo. I hope you have a better understanding about static properties. Thank you for watching. See you.